Assalamualaikum and greetings to Dr. Muhammad Hanif Muhammad Ramli. My name is Nur Rashidah binti Abdul Ghaffur and I will start my report presentation with the introduction of the company. The company that I chose to undergo my internship program is Premium Micromalt Sendirian Berhad, located at Taman Perindustrian Parit Bakar Darat, Muar Johor. The reason I chose the company is because it has always been my passion in design for manufacturing and assembly. Thus, this company really suits my desire and the earliest company that accept my internship application. Premium Micromalt Sendirian Berhad is a private innovative tool shop incorporated by Neng Boon Kiong in 11 July 2013 with a paid-up capital of Ringgit Malaysia 500,000. This company provides one-stop solution in precision connector mold design, build, sampling, and FAI First article inspection qualification. The scope of service includes design and manufacturing of precision mold as well as precision tooling supply to the connectors industry markets, including North America, Japan, and Asia Pacific. The company also capable to develop and build high complexity connector for automotive E&E, datacom, and high-speed connectors product industrial. Main software used in mold design department is SolidWorks due to its user-friendly system and has short learning cycle. From the first day of internship, I had been assigned at mold design department under project engineer. Generally, the designer will first accept the customer request by 2D drafting that were prepared by the customer themselves. The product material varied depends on what type of resin properties the customer has select after physical and chemical analysis that usually done by product designer to the product. Here, mold designer is responsible to design the mold that will produce a product with optimal quality. After all the design process were done, the latest 2D drafting produced by the mold designer will be given to the fabrication department. Fabrication department will fabricate each part and assemble to create some sample. The sampling process were done to produce some sample that will undergo FAIR, first article inspection report. During FAIR, random item will be chosen from the sample batch to be inspected whether they were produced to the exact customer requirements or not. The manufacturer will examine the sample truly in terms of its dimensions, equipment, design, and material. If the sample met the requirements, the manufacturing and production process will be qualified and mass production can be started. If the sample does not meet the requirement, such as they were air-trapped inside the mold or intolerable rough surface finish, the sample will be improved through conditioning or debugging process before being fabricated again. If the sample taken after debugging process met all the customer requirements, it will be continued to be qualified and mass-produced. If otherwise, the design will be improved until it met requirements. As an intern, my supervisor believed it is necessary for me to undergo the whole process of building the mold and insert cavity from square one. My supervisor aware that I have never been used SolidWorks before and only used CATIA during my courses. Thus, for the first 2 weeks, he fills me with a lot of SolidWorks practices consists of multiple level of difficulties to prepare for the light project. Since SolidWorks tool is similar with CATIA, I do not have a lot of difficulties to complete the task even it did take some time to be completed. On third week, I began to handle a project called ACAP, which is a plastic mold product. After receiving the 2D drafting from my supervisor, first thing to do is to understand the drawing and calculate the dimension with tolerance. The tolerance was calculated based on the shrinkage percentage. Shrinkage percentage differ with the direction flow of the resin while resin was injected into the cavity. As an example, shrinkage along flow estimate 0.3%, shrinkage across flow estimate 0.4%, while shrinkage mixed flow estimate 0.55%. The data then tabulated in an Excel spreadsheet that has been customized to estimate the design dimension after the shrinkage applied. The customer requirement dimension was replaced by the new design dimension. One mold consists of mold base, cavity insert, and standard components. These three components can be differentiated by its first number in their part name. For example, mold base start with 0, cavity insert start with 1 and 2, standard parts start with 5, and also has the standard parts that has an alphabet name. In cavity plate, there was space called pocket. Pocket is the space left during fabrication to be filled by the cavity insert. Before creating the model, the parting line, size of the pocket, size of the mold, and product shot were decided. Based on the altered 2D drafting, the 3D drawing was carried out using SolidWorks software. The first part need to be built is the plastic mold base, which will be referenced to draw the mold plate and mold insert. Mold insert is actually a separated mold base. The technique of drawing the mold may vary with people, but the easiest method recommended is by drawing the part that will be referred by the part after it in terms of its position and axis. This method will facilitate with the process of 3D full assembly. The next process after completing the mold base is to create the layout and runner layout of the mold. Mold runner consists of multiple components such as sprue, runners, and gates that work together to direct the plastic flow into the cavities. The gate that I used in this project known as tunnel gate. There were a lot of type of gates, but tunnel gate were chosen as the most suitable gate for this product. Tunnel gates are fabricated below the separating line so that they can be mechanically trimmed as the part is ejected. This kind of gate is frequently used in injection molding for tiny parts, high cavitation molds, or circumstances in which gates must be automatically removed. Next step is to build the mold base. Mold base consists of multiple plates such as top plate, cavity plate, base side backing plate, spacer bar, ejector plate, and sensor cover plate. Multiple parts such as cartridge heater, guide pin, return pin, and ejector pin work together with this part to hold the mold in place. First two parts that need to be done were cavity plate. Cavity plate or mold solid consists of two sides, which are fixed solid and move solid, separated by a parting line. The mold's parting line is the line where the two halves of the mold meet. Cavity plate were built based on the plastic mold base were located. The method is to insert plastic mold base, then to draw the mold solid in its place using SolidWorks tools such as extruded boss and extruded cut. The process of building the mold solid is a bit complicated. Thus, the supervisor provides with the example of 3D mold drawing as reference. There are a lot of new tools in SolidWorks that were learned here, such as split, move face, and combine. The order of creating this part is started by arranging the fixed solid and mold solid in the line, then to draw each parts in their exact position. Again, this is to facilitate with the 3D assemble process. After that, to build the insert cavity parts. The insert part consists of multiple parts such as fixed part, move wedges, and move gate insert. All the insert cavity part were the part that I cut from the mold base instead of building the part from scratch to reduce human mistake in dimensions. The cutting line that were decided right from the start were done to reduce the cost when the parts worn out. Easily wear entire part can be replaced by new one without replacing the whole insert cavity. The separated part of cavity insert were added with shoulder. Shoulder is the different height at the bottom of the part to facilitate the fabrication team to assemble the part without making any mistake. After all the parts were done, I then assembled the parts by inserting the parts one at a time. Assembly process has 5 different stages according whichly. Assembly process. After all the parts were done, I then assembled the parts by inserting the parts one at a time. Assembly process has 5 different stages accordingly, which are sub-fixed assembly, sub-move assembly, full sub-assembly, mold assembly, and lastly, full assembly. The assembly process were done using MIT tool, and interference tool. In my personal thoughts, assembly process in SolidWorks are simpler than CATIA. Each of the assembly stages need to be inspected whether there was any interference before proceed with the next stage. This is to ensure a smooth procedure of assembly, which the designer do not need to go back and forth to inspect the assembly drawing, while it can reduce time consumed to finalize the assembly. While I was assembling the product, there were multiple interference can be detected caused by extended parts. To overcome this issue is to go back to the part drawing and modify the drawing to fix the issue. After all the parts were assembled and no interference detected, the next thing to do is to insert all the standard parts that were provided by the supervisor. Afterward, the 2G drafting were carried out. For every part, the dimension labeled were followed by the tolerance. The tolerance was stated as reference for the fabrication department about the accuracy of the part dimension to ensure all the mold parts can be connected. For assembly drafting, the full assembly drafting, which consists of 5 pages, were done only for fixed sub-assembly, move sub-assembly, and full assembly. The bill of material were added along with other information such as heat treatment, material, part name, and supplier. The section view were added too in the sub-move assembly to show the overlapping parts in the assembly. After all the drafting were done, the drafting were inspected whether all the components were dimensioned before handed to the supervisor to be elaborated. Once in a while, I was assigned to do multiple tasks to assist the designer, such as completing the tooling qualification revision record, update the latest revision for 2D and 3D drawing, update the assembly drawing for some project, also to do the PowerPoint for mold device such as hot tip or hot sprue, to be used as reference for the workers. Recently, I did the temporary cavity plate as steel quotation for the customer. In summary, I think this company is suitable for internship program as it provides a lot of knowledge about the mold manufacturing and assembly process, also expose the intern to the real procedure and skills that need for the career. The working environment here is also healthy and helpful as all the workers is happy to answer any question they were asked. The facilities in the company is also good and clean. That's all, thank you.